All right, if we are multiplying two numbers together and they have the same sign, what happens? You get a positive result. If you have two numbers and you multiply them together and they have opposite signs, what happens? You get a negative result, okay? I want you to notice the difference in the way that these three problems right here are written. We have a negative out front, and then parentheses around the 3/4, parentheses around the 3/8. What is the sign of the 3/8? What is the sign of the 3/4? They're both positive. But then the negative sign out front says, go ahead and do this multiplication here, and then we're going to make it negative. Okay? It's important that you see that distinction. Notice on this one we have what? Positive 2/9. And on this one we have, this is clearly a negative 1/2, right? Okay? On this one, that's a negative 2/5, and that is a negative 5. So notice the three different ways that this is written. Watch those parentheses and make sure you understand how these things are supposed to go. Okay? Now, we do have two positive numbers being multiplied together here, and then we're going to make them negative. So that's where the negative sign comes from. Then we multiply across. We talked about that last time. 3 times 3 is 9, divided by 32. So 9 30-seconds. I don't know why that looks like not a 9, but it is. 9 30-seconds. And it's negative because of the negative sign that was out front. For the second one, 9/2 times negative 1/2, what are we going to have? I got 2/18. Is that it? It's a negative result. So, let me do that so that it looks like a negative result. And now what? Reduce. So our answer is actually going to be what? Negative 1/9. Don't lose your negative signs. And finally, on the last one, that's a 9/32. I don't know why the pen did that. It is the pen. Negative 2/5 times negative 5, what do we need to do here? Yeah, good. Put the 5 over a 1. We're multiplying fractions. Once you put the 5 over 1, now you can clearly see what's on top and what's on the bottom, and now you're not going to make a mistake. So what do we get? Okay, I got a 10 over 5. What's the sign? It's positive. Anything else? Reduce, what do you get? Just 2? Okay, there's two ways you could write that. If you reduce, you get 2 over 1, because you divided the top by 2, you divided the bottom by 2. But 2 over 1 is just 2. This is the answer we're going to look for, but I want you to know that this is also correct as you reduce. I want to see this. I wouldn't get too upset about this on the homework, but I don't want that. I want that, even though they're both correct. Questions on that? So I'll write, for what's a reciprocal, I'll write a fraction that's flipped. All right, we have two other things we're going to put here. There's another word, or there's another phrase, it's a vocabulary term, that we can use for reciprocal. Do we remember what that is? The word we're looking for, the phrase, is multiplicative inverse. They mean, that word, that phrase means the exact same thing as reciprocal. Multiplicative inverse. And then I'm just going to put some symbols down here. If I have A over B for my third definition, if I take the reciprocal, what do I get? B over A. So this is an arrow over, I get B over A. So that's the algebraic way to say that's the reciprocal. All we're doing is we're flipping the fraction. Does the sign change? No, just flip the fraction. That's the reciprocal. So at the bottom, 3/8 turns into what if I take the reciprocal? 8/3, good. And negative 2 4/5. We're not changing the sign. What? How did you do that? 5/14, negative 5/14, hopefully. Good. If you remember back to the beginning of this year, I said we are going to get away from using mixed numbers, and we're only going to use improper fractions most of the time. The reason for that is if we use mixed numbers, we're constantly switching back and forth between mixed numbers and improper fractions. So let's just work with improper fractions. I have to turn this then into 1. How do I do that? Take the denominator times the number out front. 5 times 2 is 10. And then I add the numerator, so 10 plus 4 is 14. The sign has nothing to do with converting into a mixed number. So this is negative 14/5. Now when I take the reciprocal, what do I get? Negative 5/14. Does it matter where I write that negative sign? Should that negative sign be on the 5 or the 14? Does it matter? That's my question. No, it doesn't matter. You can write it on the 5, you can write it on the 14, you could write it out front, as long as it's not on both numbers. One or the other, or out front, but never both. How about the floor? How do I change it to a fraction? So put the 4 over 1, and now the reciprocal is obviously 1/4. And then negative 1/6 turns into negative 6 over 1, which is just negative 6. So hopefully that's kind of an easy one for you guys to handle. To divide fractions now, we need to flip the second fraction first. We can't actually divide fractions. If you have a fraction divided by a fraction, we can't do it. We have to sort of modify the problem so that there's multiplication going on. And then we can multiply like we have been. In order to modify the problem, remember that. Leave it, change it, flip it. Have you heard that before from somewhere? Somebody somewhere said leave it, change it, flip it. Leave it, change it, flip it is a shortcut to help you remember how to work with division problems involving fractions. I'll show you in a little while why leave it, change it, flip it works. But for now, leave it means leave this fraction alone. So I'm going to write 1/3. We have division going on in the middle. Change it to multiplication. So it's 1/3 times. And then flip it tells me to take this last fraction and flip it. Take the reciprocal of it. So that becomes 2 over 1. So now we have 1 times 2 over 1, which is math that we actually can do. 1 times 2 is 2. We're multiplying across. 3 times 1 is 3. The answer is 2/3. So in your mind, when you see division problems involving fractions, leave it, change it, flip it is the shortcut. So what should I do on 3/8 divided by 2/3? Leave the 3/8. Okay, change the division to multiplication. Flip the 2/3 and I get 3/2. All right, now we can multiply. What do we get? 9/16. Does that reduce? The only factors of 9 are 1, 3, and 9. Do any of those go into 16? No. So that's the answer, 9/16. All right, on the third one, 3/4 divided by 2.5, what do we do? Very good. That mixed number needs to be turned into an improper fraction. I'm actually going to do that first before I do leave it, change it, flip it. Okay? So I'm going to rewrite 3/4 divided by, and now 2.5 turns into what? 5 over 2. Because 2 times 2 is 4, and then 2 times 2 is 4, and then 4 plus 1 is 5. So now that's what I'm dealing with. And our next move is going to be what? Leave it, change it, flip it. So leave it. 3/4 stays the same. Change it from division to multiplication. Flip it from 5/2 to 2/5. And then what do we do? Multiply across. 3 times 2, 6 over 20. And this does reduce by a factor of 2. So what do I get? 3 over 10, 3/10. That's my answer, 3/10. All right, the last one, negative 1/5 divided by 3. How do we do that? This is just an integer here, so we're going to put that over 1 so that we can see that it is a fraction. And now when we leave it, change it, flip it, we shouldn't make any mistakes. So what will I write? Negative 1/5 times 1 over 3. Anything else? Okay, just multiply across. What's my sign going to be? Negative 1 over, good, 1 over 15. Negative 1/15 is the answer there. So if you have a division problem, you can use leave it, change it, flip it. In fact, you have to in order for you to be able to solve the problem. If you have a subtraction problem, what's the little 3-word thing for that we learned in the last section? Keep, change, change. Okay? That's for a subtraction problem. Leave it, change it, flip it is for a division problem involving fractions. All right, so let's try to remember that something I've said already this year is a fraction is really just a division problem that what? A fraction is just a division problem that hasn't been finished. It's not done. We just don't do the division, okay? So that's all a fraction is. So if I have 8 divided by 4, I can rewrite that as a fraction without using the elementary division symbol anymore. How would I write that as a fraction? Yeah, 8 over 4 is the same as 8 divided by 4. In fact, if you were to read that, you would say 8 divided by 4. It's the exact same thing. Does that reduce? 8 divided by 4? 8 divided by 4. What's 8 divided by 4? That's 2. So that's your answer. You reduced it technically. It's a fraction. 8/4 reduces down to 4/2, which reduces down to 2 over 1. 2 over 1 is just 2. Or you could say 8 divided by 4 is 2. How can I write this one? 3 divided by 6. 3 over 6. Does that reduce? That becomes 1/2. And that's your answer. Yes, it's a fraction. The original problem, 3 divided by 6, we can't do that and come up with a nice even, like not even, but a nice number. So we write it as a fraction, we reduce it. That's all these are. How about 1 divided by 9? 1 over 9. And how would we read that? 1/9, all right? So this division problem turns into the same division problem, but now when we look at it, we see 1/9. We don't read it as 1 divided by 9 anymore. You could. That doesn't simplify, so that's the answer. That's where fractions come from. They're just a division problem, written differently. All right, it's time now to learn where leave it, change it, flip it comes from. And the best way to learn where it comes from is to look at this problem right here. It looks crazy. It looks like 2 divided by 3 divided by 1 divided by 4. Technically, that is what's there, if you include commas or grouping symbols around what I just said. What we have actually is 2 fractions that are being divided. We have the numerator fraction 2/3, and we have the denominator fraction 1/4, and they are being divided. So hopefully with those colors on there you can see how there are 2 different fractions. The numerator is 2/3, the denominator is 1/4. This is an illegal format here. We can't have an answer that looks like this, so we have to modify it. We have to get it down to where it's just one fraction, kind of like 1/9. And it's a little trick of math that we're going to do to make that happen. What I want to do is, if I have something divided by 1, I just get that something, right? Like 4 divided by 1 is just 4. The divided by 1 part kind of goes away, right? You guys agree with that? Yeah? Isn't 4 over 1 the same as just 4? Okay, so that over 1 part allows me to not write that denominator anymore because it's over 1. And I can now just write the numerator. Do you agree? Okay, so if I want this denominator to disappear so that all I have to do is write the numerator, then I need to turn the denominator into a 1 so that I have something divided by 1. And then I can just say that it's this something up top. You follow that? Okay, so now the question is, what can I do to the denominator to make that 1/4 turn into a 1? Because I'm dealing with just, like, not an equation, I can't add or subtract anything to both sides. But what I can do is multiply. I'm going to multiply by something so that I wind up with 1 in the denominator. What can I multiply 1/4 by to get 1?
To get what?
1. We're not dividing, we're multiplying. What can I multiply 1/4 by? 4 over 1. What is 4 over 1 compared to 1/4? What is 4 over 1 compared to 1/4? It's the reciprocal, yeah. If you multiply any number times its reciprocal, you get 1. So I'm going to take the reciprocal of 1/4 and multiply it times 1/4, and I'll get 4 over 4, which reduces down to 1. I've just turned the denominator into 1. The problem with what I just did is I can't do this unless I keep this thing exactly the same. I can't multiply this fraction by any number except for 1. And I didn't just do that. I just multiplied the bottom by 4. 4 over 1, technically. So I better do the same thing to the top. What do we call what I'm doing right now? If I'm writing the same thing on top and the bottom and I'm multiplying. It's a fancy 1. Yeah, there's a fancy 1 going on here. It doesn't look like 1, that's why we call it a fancy 1. 4 over 1 divided by 4 over 1 is the same as 3 divided by 3. It's the same as Jake divided by Jake. It's 1. Okay? So we have 4 over 1 divided by 4 over 1 right here. This is a 1. Basically all I've done is I've multiplied this fraction times 1. Did I change the fraction? If I have 2/3 and I multiply it times 1, do I get 2/3? So if I have this fraction right here and I multiply it times 1, did I change the fraction? No, I didn't change it. Is it going to look different? Yeah. But I didn't change the fraction. Okay? It's the same exact fraction. So now when I multiply across, I get 4 over 4 on the bottom, which is just 1. On the top, I multiply it across, and look at what I have. 2/3 times 4 over 1. If I were to write this original problem here, 2/3, the elementary way, I'd write the division symbol and then 1 over 4. And based on what we were doing on the previous page, we said use leave it, change it, flip it, right? That would give me 2/3 times 4 over 1. Well, look at what I have right here. The exact same thing, 2/3 times 4 over 1. This is leave it, change it, flip it right here. So leave it, change it, flip it is a way to remember how to do what I just did right here with fancy 1s. There is math behind it. Anytime you're taught a shortcut, generally it's going to be some sort of fancy 1 going on behind the scenes that allows that shortcut to happen. And this is the fancy 1 right here that allows leave it, change it, flip it to happen. So, do you just need to remember leave it, change it, flip it? Sure. Remember that. But also remember behind the scenes why it works. So now we multiply across. 2 times 4 is 8. 3 times 1 is 3. I have 8/3 divided by 1, which is what? 8/3. 8/3 is the answer. Let's use the fancy 1 method that I just showed you to solve that first one there. I want you to see the leave it, change it, flip it a couple more times, how it actually works. So I want to turn that denominator into what? 1. My denominator currently is 3/10. So I need to multiply times a fancy 1 so that I get 1 in the denominator. My fancy 1 is going to be, so 10/3 in the denominator, and what in the numerator? Same thing. Otherwise it's not a fancy 1. 10/3 divided by 10/3 is just 1. Okay, so in the denominator now we have 3 times 10, which is 30. 10 times 3, which is 30. 30 divided by 30 is 1. Perfect, that's what I needed. Up top, we have 9/5 times 10/3. What do? Multiply across. So we get 90 over 15, all over 1, which we know we don't need the over 1 anymore, so 90 over 15. Does that reduce? Yeah, to what? 6. Yeah, 90 divided by 15 is 6. Do you see the leave it, change it, flip it here? All right. This last one is kind of confusing. You have to make sure that you identify what the numerator is and what the denominator is. So what's the numerator here? It's 5/6. This bigger, thicker fraction bar right here is showing me that I have a numerator here and then a denominator here. So the denominator here is actually what? It's 4 over 1. Now I want to turn that denominator into what? I want it to turn into a 1. So I'm going to multiply times 1 over 4. Where? On both, top and bottom, that's right. 4 over 1 times 1 over 4 is 4 over 4, which reduces down to 1. And then 5/6 times 1/4, 5/24. Is there anything wrong with what I have up here right now? What was that? Yeah, don't forget your negative sign out front. It's easy to do. Be careful with your negative signs. Get in the habit of always looking, did I lose my negative sign? What now? So my answer will be negative 5 over 24. Okay? Could you do leave it, change it, flip it instead? Actually, you did anyway, right here. You're doing no extra work by doing what we're doing here than you would be by writing this down and then times and then this. So stick with what I've shown you here.